Hi, this is John Beck. In this video for CIS 117, we're going to take a look at creating and using a stored procedure, and we'll also take a look at creating and using a trigger. And you could think of a trigger as simply being a procedure that is executed automatically when a certain event occurs. The typical events that we link up triggers to are inserting, deleting, or updating records in the table. And so we'll link up to one of those events. Let's start, however, with a stored procedure. A procedure is just like a function that you define, so it's a user-defined function or routine that can be called to execute something, and it has the advantage of being pre-compiled. So it's already got a query execution plan. The query optimizer is going to be able to run it a little more quickly. It's a little more resistant to being hacked because unlike dynamic SQL that you would create interactively, let's say through a user web form or something like that, where that string might be altered or something inserted into the query, everything that we send as a value to a procedure is bound as a strongly typed variable. And so it's a little bit more secure. And so in addition to being very, very useful, it's a little more secure and tends to execute on average a little bit more quickly. So procedures are really good and useful things. In this example, we're going to parallel the exercise in TAL 5A, which says write T-SQL procedures to, or in this case, a procedure, to obtain the name and credit limit of the customer whose number currently is stored in iCustomer num, or in this case, that would be more of an Oracle variable. Let's rewrite that so it says in at cusnum. And then to place these variables into the other variables, and again, we'd have to rewrite those Oracle variables. Let's hit enter and bring this around so it's easier to see. Place these variables in iCustomer name and iCredit limit respectively, output the contents of iCustomer name and iCredit limit. What we're actually going to do, that's a little bit more Oracle oriented. So let's rewrite that. So it says place these variables in the variables, and we're going to make it well, actually, we're going to output them as fields, so we don't even need to output them as variables as we would in Oracle. So you could say display these values, and period. That's it. Okay. So in doing that, we're going to create a procedure. We're going to call it by convention USP. Is a naming convention that's often used. You can choose any legal name, but USP tells you that it's a user-defined stored procedure. The system also has a lot of predefined stored procedures, which are just prefixed with SP, and then some meaningful name. So disp cred, so display customer credit, that makes sense. And we're going to take the customer name as, or customer number as a char3. And that might also be a better choice on a well-designed database as an int rather than as a char. If that's the customer number and that's the primary key, it's probably a synthetic key and it's probably going to be a number, so we could use an int for that. Char is kind of convenient because the auto conversion will work for us, and as long as 3 is long enough, that's fine. That would allow you to choose customers from 0 to 999, but you might want to think ahead, rethink that if you were designing this for an actual database, because that number might be quite a bit longer and char3 is not going to do it. Okay, so, and we design that as, and then everything under the as is just the usual query that we would run if we were doing it longhand. So select customer name, credit limit from customer, where customer number equals, and here's the only place we have a little difference. We put our variable expression. Variables are denoted by a leading @ sign, at cusnum. So this is a variable or a replaceable parameter. And then after we have created that procedure, we're going to test run it using exec, calling the USP name and giving it the variable assignment. So at custnum equals 126 means it's going to call it for customer 126, and then we'll see what that does for us. So let's go ahead, highlight the portion of the query we want to execute to create the stored procedure. And that completed successfully, so that should now exist. So now we should be able to execute that. And there it is. So that gives us the customer name and credit limit for customer 126, Toys Galore, $7,500. And then when we're all done, if we are cleaning up our environment, we're not going to leave that in place. We can go ahead and drop that procedure. Ordinarily, we just leave that in place because we've now got the procedure built that is going to be available for use. But I'm going to clean that back up just as a good habit in doing our lab exercises. And now that's been dropped, and if we were to try and run this again, it won't be recognized. So it doesn't find it. I could go ahead and recreate it, but I show you that. So as you're building these things, if you make an error and need to revise it, that's how you would drop the procedure you created and could start over again. Okay, very good. So that is, pardon me, an example of creating procedure. Let's take a look now at a trigger. And again, a trigger is like a procedure, but it's going to happen automatically when an event fires. So the event that this is going to be bound to is after an insert happens, okay? And so immediately after an insert occurs, this trigger is going to automatically be invoked. And this trigger, we're going to give it a meaningful name, add rep com, which is add the representative's commission. It's going to operate on the customer table. After an insert occurs on the customer table, then it's going to do as the following. So you have the variables being declared. So we have the balance, customer balance, going to be decimal 82. We can look that up right in the table definition for the database. And we're going to select that balance, and we're going to get that from inserted. What is inserted? Inserted is a special table name, and the last record that was inserted is held in a buffer, held in a temporary table called inserted. And so we can go and find out what that was just inserted. So we selected the balance from the thing just inserted. And now we're going to do a normal update SQL statement. We're going to update the rep table. We're going to set the commission, the amount of commission earned is whatever it is currently, plus the commission rate times the balance, and that is going to add in the representative's commission that he just earned automatically, which is pretty cool. So anytime a customer order is taken, then we're going to go ahead and give the rep some commission on that. So neat. And so let's go ahead and install that trigger. Command completed it successfully, so that has run. And then let's run a series of transactions here. We're going to select all the output for rep 30, and then we're going to run an insert, adding a customer widgets and wonders. And oh, you know, I probably left that in there from the last time I was testing that. So in addition to drop the trigger, I'll need to delete from customer where customer num equals 999. Let's clean that up right quick. Oh, not deleted. Delete. Oh, don't want to run the whole thing, just that one. Okay, so I've cleaned that up, and let's go ahead and make sure I've got that trigger dropped. Okay, so now let's go ahead and install that trigger. Okay, so the trigger's been added, and now let's run this series of transactions. Let's look at what the rep 30's commission balance is, and then let's go ahead and add in a new customer, and then go ahead and take a look at what that changes to. If that trigger fires automatically, we ought to see a difference in the commission. So let's go ahead and run that and see if that works as we expect. And make a little more room here. And so here we have rep 30, and before the insert, the commission was 4130.46. Then we fired off that insert, and the commission is 4140392. And so that happened automagically. You like that term, automagically? Because it is half magical. It's automatically done the update on the commission. And this is a great way to implement business rules right in the database. So the data actually adopts a kind of a behavior. So anybody now using an outside transaction, so if you build web-enabled databases, or you build applications, fat clients or thin clients to talk to the database, when they do these things, the business rules of paying the commission to the rep happens automatically. And that's a really, really good and powerful thing. It also means that if you need to update this, so if we have a different rule about how we do the calculation of the commission down the line, we can change it in one place here at the database, and all of our applications downstream on the web, in a fat client, in a thin client, however our database is getting used on an iPhone app or an Android app, if it's using the database, it automatically inherits all that creamy, golden, delicious goodness, and that behavior happens because we've made it a rule right in the database. And so our programmers don't have to be involved with that end of the business logic, and you don't have the problem of, well, if I've got iPhone apps and Android apps deployed, do I have to update the code base on all those devices all at once? It updated here in the central database, and everybody just inherits that, and you don't even have to roll out new code. You don't have to make everybody download a new iPhone application or new Android application in order to get the updated version. So that works pretty slick. All right, and let's go ahead and clean up after ourselves. So again, you would normally leave this in place, but in an exercise, a student assignment, we might want to clean up after ourselves, and you're going to need to probably recreate the triggers several times as you debug them and improve upon them. So let's drop it, and then the other thing to remember to do is I'm going to drop that customer that I have just added. And of course, the other thing you can do if you get into trouble with that is you can always rerun the full database create script. And for the TAL database, there's a separate drop script. For the CIS 117 database, when I built that script, I put it all together so it will actually drop it and recreate the whole schema all at one shot. So that's it from now. I hope that is useful to you, and you have a final exam coming up. Study hard, and I wish everyone great success. It's been a real pleasure to work with you this term.